Welcome everyone to my class today. In our last class, we discussed the resultants of two forces acting at a point and resolution of forces. Today, we shall go further to look at resolution of several concurrent forces. But before we do that, let's state our learning objectives. At the end of this lesson, students will be able to resolve several concurrent forces. And secondly, we'll be able to determine resultants of the resulting vertical and horizontal components and its direction. We've laid some foundation in our last class, so let's quickly forge ahead to the first example. Example 1. So the first thing we are going to be talking about here before we begin the example 1 proper. Now look at this formula you are seeing on the screen. Now what you are seeing here is for my y-axis, y. For my x-axis, you can see on that screen in that formula summation py, and you can see summation px. It means we are going to resolve the forces given, all of them to the vertical, and we also resolve all of the forces one by one to the horizontal as well. Okay, that's why you have summation. We're going to add up. Then before we can now obtain our resultant, this is r. Okay, and we have a theta here. Of course, we know that that this angle here, that's showing the direction of the resultant, will be obtained with that tan theta equals summation of py over summation of px. Of course, tan theta is opposite over adjacent, so this opposite is summation py, then the adjacent is summation px. Okay, so that's how we obtain that formula, simply SOHCAHTOA, summation of py over summation of px. So that's the basis of what we're going to be doing today, and that's the foundation. So we're going to take two examples. Let's take the first example 1. Two forces P and Q act at a point as shown in the figure below. So there's a figure we're going to be seeing in the next page or the next slide. The P is 55 newtons and my Q is 86 newtons. Find A, the horizontal and vertical components of the resultant force, and the B says the magnitude of the resultant force, and C says the angle which the resultant makes with the horizontal. Now let's move ahead. Good. And this is the diagram that was mentioned below connected to this particular question. Okay, let's go to the solution proper now. So we are going to resolve the two forces that we can see on that we saw in the question. We have something like this. It's like a reminder. I have something like this. I have a Q, force Q here, then I have force P here. Then one is inclined at an angle of 60 degrees. One is inclined, this is 60, and this is 50. Okay, so we have two forces. This is just a reminder of the diagram we saw earlier on, forces Q and P. Now what will I be doing here? I'm going to resolve force P to the horizontal first, then I will also resolve force Q to the horizontal. How do we do that? What we are simply applying is SOHCAHTOA. So to resolve this force P to the horizontal, I want to resolve to the horizontal. This place becomes my what? Adjacent. This is adjacent side. And this, what I have here, the P will always serve as my what? Hypotenuse. That means it's going to be cosine. So to resolve P, I'm going to have 55 cos 50 degrees. I'm resolving to the horizontal, that's the adjacent. That force is like the hypotenuse. That force is like our hypotenuse. So we're going to apply 55 cos 50 degrees. So 55 cos 50 degrees, we resolve that. So punch your calculator, you have that value. Now I want to resolve the same Q to my horizontal axis, that's horizontal components. Okay, what would that give me? Notice if I resolve this force Q to the horizontal, this part of the plane is negative. So that's horizontal component. That's why you see the negative that is here. That's the negative sign you have there, because the force is towards what? The negative side of x-axis. So we are going to put our negative there. So we have, I want to resolve to the horizontal minus 86 cos 60 degrees. So of course, if you multiply, I have minus 43. That's this answer here. So I'm going to sum up all I have in my horizontal component. This is horizontal component. This value is also horizontal component. That's why we have summation. We want to add. Okay, this is horizontal component rather. This is the final answer. So I add these two in circle. If I add this and this, the result becomes minus 7.65. That's the value I have in my horizontal component. Now I've gotten a horizontal component. Now let's resolve each of the forces to the what? To the vertical axis now, or which we call vertical component. I want to resolve force P to the vertical. If I'm resolving to the vertical, that's going to be what? That vertical will be, if I have something like this vertical, that's facing the angle, that's opposite, then the P itself is hypotenuse. So I'm going to have a sign. So I have that force P, which is 55. Don't forget, our force P is 55 given. So 55 sine that angle. So punch your calculator, we have that value. Then to do for Q, we have 86 sine 60 degrees. Now look at this. If I resolve this to this vertical, if I resolve this to the vertical axis, you notice that this time around our vertical will still be positive, because this part that I just put the arrow now is what? Positive y-axis. So our value is going to be positive. So if you simplify 86 sine 60 degrees, I'm going to have this value. Okay, now I've been able to resolve the two forces to my vertical component. So I'm going to add. So this summation py represents vertical what? Vertical component. Vertical represent my vertical. So I'm adding the two. I'm adding this value and also this value that I have here, and both of them gives me 116.61 newtons. So this is the summation of my what? Summation of all my forces along the what? Y-axis. That's what we call the vertical component. Now let's move to the next slide and conclude the solution. Good. How do we get our resultant now? What we are simply applying there is just Pythagoras theorem. Don't forget, now we have something like this. Let me write. I have something like this. Good. I have something like this. My resultants, these resultants, my summation. I'm showing you this again. Summation py is already here. Summation px is already here. Now I want to find the resultant. What I'm simply applying is Pythagoras theorem. Pythagoras theorem. Okay, remember this should be angle 90. We are applying Pythagoras theorem. That's the foundation of that formula that was given to us. So my summation of if I square each of the value I have, I'm going to have this plus this. The value we obtained before, if we square them, I have this. If I square the summation of my both px and py, I have this. So if I add this value and this value, it gives me this. So square root of this value gives me 116.9. Just find the square root. Remember the formula we wrote before. We said r is just square root of summation px squared plus summation py squared. So don't forget, after that summation px is squared, summation px, after squaring it, that's where I have 58.52. Okay, then after my summation py is squared, that's when I have 13,598. Good. So these two values I have here is as a result of squaring summation px and then summation py. So of course, when you add, you have that value. Find the square root. You have what you have on the screen, 116.9. Let's quickly find the angle of inclination of the resultant. So we want to get the result, the theta now, the direction of the resultant, which is summation py. Summation py that I obtained before, I have 116.6. Remember, we obtained that value before. Then I have summation px minus 7.65. So substituting that and finding value of theta. So this is tan theta. So when you find the arc inverse, remember the theta will be tan inverse of the answer we have there. So that gives us approximately 93.75 degrees. Good. So that brings us to the end of this example. Please, if you have questions, don't forget to post your question as after this video. Put your question and post your comment. All shall be duly attended to. Okay, I believe we have done justice to this particular question. Let's forge ahead. Can we quickly look at the second example? Find the resultant of the forces shown in the figure below. We want to find the resultant of the forces shown in the figure below. This is the figure that we have. We have this figure. Okay, let's see how this particular solution goes. So this time around, I have three forces. Force one, I have three forces. Force one, the second, then the third force. I have three forces. Okay, so let's see how we are going to resolve each of those forces. To the horizontal, we now sum. Then we also resolve each of the forces to the vertical. We also sum. That's how to do it. After resolving to the horizontal, you add up. Then after resolving to the vertical, you also add up. So let's see how this particular one goes again. Good. I hope we are following in this class. The horizontal components. Let's take the horizontal component. Now let me make a sketch here so that we can see what this question is all about. I'd like to remind you of the sketch again. Just something like this I have in that page. Here I have 80 degrees. here I have 5 newtons, I have 4 newtons. That's the diagram, just to remind you of what the diagram is. Here is 10 newtons. As you can see, our 10 newtons is already in what? Horizontal. So we need to resolve the 5 newtons and 4 newtons to the horizontal first. Okay, so if I try to resolve that, what do I have? Don't forget, we have something like this. We have an angle 130 degrees here, 130 degrees. Okay, so if I have that angle, so what does that mean? Now let me do simple construction here, a simple construction that will make you to understand what we are talking about. Let's assume I have a straight line. The straight line continues like this. Okay, if here is 130, it means the remaining part of this is what? If here is 130, here will be 50 degrees. Okay, so it means the remaining parts here will now be what? 30 degrees. That's how we are going to divide the 80. And sum of angle on a straight line, I've made a sketch. Can you see the sketch? So that 130, I've extended the horizontal line. So from there, I know that 50 is there. Then below 50, I have 30. So 50 plus 30 will still give us the 80. So I've broken down the angle we have there into 50 and 80 degrees, as you can see on that on the screen there on the board. Good. Now I'm going to use my, don't forget, when we are resolving, we can only make use of the angle to the horizontal or to the vertical. So 80 is not to the horizontal or to the vertical. 80 is showing an angle between forces 5 newtons and 4 newtons. So I can't use that 80 the way it is. So what I'm going to do is to break down the way I've done it so that I can know the actual angle that we are having to the what? Horizontal. So that's why I've done that. So if I want to resolve 5 newtons now, the 4 newtons and the 5 newtons, look at it. This, remember, this is 4 newtons. The other one is 5 above it. Okay, now if I resolve 4, don't forget the angle, the 4 is representing my hypotenuse. So if I complete the Cartesian plane, okay, the 4 is my hypotenuse. The horizontal that I'm resolving to is my what? Adjacent. That's cosine. So I have 4 cos 30 degrees. If I say 4 cos 30 degrees, I have resolved 4 to the what? To the horizontal. So the value of 30 degrees is 0.8660, and that gives us this answer. So if I resolve 5, remember our 5 is the one above, this is the 5, okay? That 5 is also making an angle of 50 to the x-axis. That will give me what? The same thing, 5 cos 50 degrees, okay? As you can see, 5 times that value, this is the value of my, that value here, sorry, that's my cos 50 degrees. If you multiply both together, I have this. Now the 10 is already in the position of the horizontal, so obviously nothing has changed there. It will remain 10. So the angle we are using here is already, it will be 0. This angle, the angle we are using for this one will be 0 degrees because it's already on the horizontal. It's parallel to the horizontal. Okay, so no angle there. So that's why I'm choosing 0 degrees. So that 0 degrees is going to be 1. Don't forget, I have this minus here. Why? Because this part is negative in our Cartesian plane. Okay, remember, when you have a Cartesian plane, this part is negative, this part is positive for our x-axis. Okay, don't forget, and that's why I have that negative value there. Okay, that's why I have the negative value. Let's quickly conclude this part. So now my summation px, I add the three values 1, 2, 3, adding all of them together, I have this. That's simple enough. Now let's resolve the same forces, those same forces to what? Let's resolve those same forces. Remember, I already have this 50 here, then angle 30 here. Let's resolve those same forces to the vertical component now. Don't forget, here was 5 newtons, here 4 newtons, here we have 10 newtons. Good. For my 4 newtons, I want to resolve it to my what? To the vertical. It's coming this way. Look at it. This is the vertical. This is the vertical. Okay, I have vertical that way. So if I resolve my 4 will come towards here. That's negative. That's why you have this negative here, -4, because we are resolving it towards negative y-axis. This is negative y-axis. That's where 4 is coming to. That's why we have that negative sine 30 degrees. Why is this sine? Look at it. This angle is facing the y, that's opposite, and I want to resolve this. This is hypotenuse, that's sine. So -4 sine 30 gives me this. So if I resolve the other one, 5 newtons that you can see here, if I resolve 5 newtons to the vertical now, I'm going to have 5 sine 50 degrees. Look at it. That 5, the force itself represents my hypotenuse. Don't forget, I'm resolving to the vertical. That vertical is the opposite. So I have opposite and hypotenuse. So I have 5 sine 50 degrees. Remember, we have a positive beside 5. Why? Because we are resolving here positive what? Y-axis. Good. That's why we have that. Now when we simplify, so if you resolve the 10 that we are resolving, the 10 we are resolving, don't forget, is already on what? The 10 is already on our x-axis. It's on our x-axis. So the effect on the vertical axis is 0. That's sine 0. The angle, okay, is 0. So sine 0 gives us what? 0. So this 10 Newton does not have any effect here. Will not have any value here on the y-axis. So it's 0 there. So we have sine 0 degrees. So we have 0. So add up everything. That's the summation of this. I add this plus 0. That gives me the answer there. Okay, good. Let's forge ahead. I hope you are following. Now let's move to the remaining parts of this. How do we find the magnitude of our resultant? We are requested to find the magnitude of the resultant. Now, what have we succeeded to do? We have succeeded to find this. Don't forget. Now I have this, our resultant. Don't forget. Now I already have the summation px and I have summation py. I have summed all my vertical components. I have that. I have summed all my horizontal component. I have this. So that's what I'm going to use. And don't forget, here will always be the theta. Okay, the theta, that's the angle the resultant is making with the x-axis to show the direction of the resultant. Okay, now what we are doing here, I've said it again, I've said it before, is we are using Pythagoras theorem. So don't forget, this is the value we have. The value we have for both summation of y component and x component, the horizontal component and vertical component. So if you square each of them, you have this. Okay, so my r, this is r squared. My r squared gives me that. So to get my r will be square root of that value. Okay, so I have 3.793 newtons. How do I get my tan theta? My tan theta, of course, you know, opposite over hypotenuse. Look at it. This is my opposite, which is the vertical, and here is my adjacent. This is opposite and this is adjacent. Okay, so opposite over adjacent. So my opposite value, that summation is this here, and the other one is 3.22. so if I do that, I have this. Okay, so the answer is going to give me what? Theta. When you find the arctan of that value, I have 28.85 degrees. So we have succeeded to find the resultant, and we have also succeeded to find the inclination of the resultant to the axis. Okay, inclination of the resultant to the axis. Okay, let me quickly change something here. Okay, see what this diagram is supposed to go the other way, like this. That's why we have that negative. Really, that's why we have the negative. Okay, supposed to go the other way. This is the angle. I've obtained my result. This is the resultant. Remember, the value we got was negative. Okay, was negative. Let me just show you. Okay, the value we got for our summation x was negative. Can you see? That's where I have my hand right away. Negative, and the other one was positive. That's this. Good. So the diagram we drew supposed to have gone this way. The theta here. Okay, so though it's still the same thing, I have my minus 3.322 here, and I have 1.83 newtons here. Okay, so that is what we are using. So 1.83 over 3.22, so that gives us that value, and if you simplify, I'm going to have 28.85. You have a question? The negative is actually just showing direction. The negative is showing us direction, just to show us the direction of the force. That's the negative. So if I find arc tan of 0.5509, my answer will give me this. I think we have done justice to the examples we have today. Let's quickly summarize. As you can see on this screen, our last page, you see that this is the summary of what we have used today. That's the summary. The summary of what we have used today is what we can see on the screen here, both this and this. And you see that what we are doing here is what? Pythagoras theorem. Pythagoras theorem, that's what we are applying. Okay, so easy, right? Now our tan theta will always be summation py over summation px. Don't forget, you need to consider direction. You need to consider what? Direction. If I am to resolve a force this way, if I have a force this way, if I'm resolving this force, this one here, let's assume this is a force, this. Okay, if I'm resolving this now as a summary, if I'm resolving to the vertical, okay, and it's going to carry a negative because this part of the y-axis is negative. I'm resolving the f to this part, it's going to be negative. And if I have to resolve f to the horizontal, this part that I'm resolving it to is what? Positive. So the value of my resolution to my horizontal axis is what? Will be positive, and the value of my resolution for this kind of force is going to be negative. Don't forget, and the sign is very important. It shows the direction of what? Of the force we are resolving. So this brings us to the end of this class today. Attached to this immediately after this period 2, quickly attempt your quiz, as we are going to take record of those that have attempted the quiz. You will see a quiz, a tile for the quiz. Click on it and make sure you do justice to that particular quiz. Thank you. Next class we are going to meet again. Our next class we should be talking or discussing equilibrium, and that's where we are going to be discussing what we call Lami's theorem. Okay, till we meet again, God bless you. Thank you and enjoy your day, and make sure you watch this video over and over again, and do not forget to post your questions, your comments, as every comment will be duly attended to. Thank you and God bless. Good, till we meet again.